This is Mr. Castillo. In this video, we are going to review Unit 2, Section C, Area and Fractional Side Lengths. The learning goals for this section are to find the area of a rectangle when one side length is a whole number and the other side length is a fraction or a mixed number. And we are going to represent and solve problems involving the multiplication of a whole number by a fraction or a mixed number. So over here, uh, let's do a little review. So for each diagram, we're going to write an expression for the area of the shaded region, and then we're going to find that area. All right, so let's go ahead and do that now. Okay, so over here, the first step when we see a diagram like this is to identify the shaded area. Let's label the side lengths. So let's, over here, it says that from here to here is one hole. So I have one hole, 1, 2, 3. Okay, so that means over here I have 3 holes in total. From here to here, I have 3 holes. Okay, now from here to here, I also have 1 hole, but I'm only looking for the area of the shaded region, not all of this. So what area is shaded over here is only one piece, right? One part out of how many? Out of 1, 2, 3, 4. So on this side, on this portion right here, I have 1/4. So we need to remember the formula for area. To find area is area equals length times width. So here we have our length of 3. So this is going to be our expression for the area. 3 times a quarter, 1/4. All right, so we're going to multiply this whole number by the numerator, and we're going to keep our denominator. And we're going to get 3/4 square units. Just going to put a U or a number 2 there to represent square units. Another way to look at this is to understand that each of these parts here, because in every hole 1 out of 4 is shaded. So how many 4s do you have? 1, 2, 3. All of this, in all of this, you have 1, 2, 3. You have 3 copies or 3 groups of 1/4, which is the same as saying you have 3/4. So you can just count these 1, 2, 3. You have 3 of those 4ths. All right, let's go on. How about this one? Okay, so in this one, we have that on this side, we can count that we have 1, 2, 3, 4. So that means that from here to here, I have 4. And of the shaded region, from here to here only, not the whole thing, because that'll be one hole, but I have 2 shaded. 2 out of what? Let me see. 2 out of 1, 2, 3. 2 out of 3. Okay, so that means that my expression is going to be length times width. So I'm going to multiply 4 times 2/3. All right, so what is 4 times 2/3? Well, 4 times 2 is going to give us 8. and that is 8/3. And we can go further than that, and we can convert this improper fraction into a mixed number by understanding that 8/3 is is a fraction that is more than a whole. So how many wholes do we have there? So, well, I know that every 3/3 is going to be one whole, right? So every 3/3 equals one whole. So how many groups of 3/3 can I take out of here? Well, I can break up 8/3. Let's make a number bond. Let's break it up into 6/3 and 2/3. I'll break it up like this because I know that 6/3, well, every 3/3 I have one whole. So if I have 6/3, then I have two wholes. So 8/3 just means two wholes plus an additional 2/3. So 8/3 equals 2 and 2/3. Alrighty. So let's continue over here. Okay, so in this one, we have to be careful here where the hole lies, right? So from here to here, you have one hole, and from here to here, you have one hole. So first of all, let's label our side lengths. So I know I have 1, 2, 3. So I have 3 holes from here to here. Okay. All right. So how about over here? From here to here, it says that I have one hole. Okay. Now, how about from here to here then? So I have one hole. So from here to here, I have one hole. And this part right here, what is this fraction here? Well, I have two parts that are shaded. So 2 out of something. Out of what? Out of 1, 2, 3, 4. So notice that my denominator is 4 because over here I also have 4. 1, 2, 3, 4. And the whole ends right there. So 1/4, another fourth, another fourth, another fourth. I have 4/4. That's one whole. And then I have another 2/4 here. So I have one whole and 2/4. So all we have to do is multiply length times width. So this is going to be our expression. It's going to be 3 times 1 and 2/4. Okay, so let's change the color a little bit. All right, so what is this equal to? Well, we have to use the distributive property, and we have to multiply this 3 times 1 plus 3 times 2/4. So our new expression is going to look like this. It's going to be 3 times 1 plus 3 times 2/4 plus 3 times 2 out of 4. All right, so let's just follow this along. So 3 times 1 is going to give us 3 plus 3 times 2/4. 3 times my numerator, that's 6. So that's 6/4. So far my answer so far, all of this is giving us 3 and 6/4. Okay, so this is my mixed number here. But again, this mixed number, it's not proper because my numerator is bigger than my denominator. So I know that in this part of the fraction, I have more than a whole. I know that every 4 fourths equals one whole. And here I have 6 fourths. So 6 fourths, let's see what 6 fourths is actually equal to. So let's break it up into 4 fourths plus another 2 fourths. Because 4 and 2 is 6. So that means this is the one whole right here. So one whole plus 2 fourths. So this is equal to, over here, let's put another color. Okay, so this is equal to 3 plus 1 plus the 2 fourths. Where does 1 and 2 fourths come from? From the 6 fourth. On the 6 fourth, the 6 fourth became this right here. So what is 3 plus 1? Well, that's 4 and 2 fourths. And 4 and 2 fourths is the same as 4 and a half. So this is actually 4 and a half square units. Another way that you can do this is that you can also, instead of having a mixed number here, you can just calculate the amount of fourths that you have here. So first you have to understand that in the whole you have 1, 2, 3, 4 parts. So you're working with fourths. So each of these is a fourth, right? So fourth, this is a 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 fourth. So how many fourths do you have on this side? From here to here? Well, let's count them. 1, 2, 3, 4, 5, 6. You have 6 fourths. Okay, which is the same as 1 and 2 fourths, right? You have 4 fourths plus 2 fourths. So you have 6 fourths. So you can also just do straight up 3 times 6 fourths, and you will still end up with the same results. All right, for the next question, we have that Paris made a flag that is 3 meters long and 4/5 meter wide. What is the area of the flag? Explain or show your reasoning. Okay, so, well, so it gives us the length, 3 meters long, and it gives us the width, 4/5 meters wide. So we're looking for the area. So what is the formula for area? Area equals length times width. So we have our length, 3 meters, times our width of 4/5. So all we have to do is multiply this whole number by this fraction to find this area. So 3 times 4, that's going to give us 12/5. Okay, so we can leave our answer there, or we can continue to convert this into a proper fraction or mixed number, because right now it's an improper fraction because the numerator is bigger than the denominator, and we know this is bigger than 1. So we know that in every 5/5, so I know that 5/5 equals 1 whole, right? So here we have 12/5. So how many wholes can I get out of there? Well, I know that 12 fifths, I could break it up into 10 fifths, right? 5 fifths plus another 5 fifths. So this means 2 wholes right here. And here I have 2 fifths remaining. So that means this is equal to 10 fifths, which is 2 wholes. So 2 wholes and another 2 fifths. So this is the area. 2 and 2 fifths square units. Okay, let's go to the next one. So for this one, we have to find the value of each expression. So we have a fraction multiplied by a whole number. So we're going to multiply 20, this 20, times this numerator, and we're going to keep our denominator. So 20 times 1, that is 20. 20 fifths. Okay, well, this means, remember that fractions are division. So 20 fifths just means 20 divided by 5. Okay, so we have to ask ourselves 5 times what will give us 20? Well, that is 4. So let's go to the next one. Here we have 3 and 2 fourths times 5. So we have a mixed number times a whole number. So the way we're going to do this is that we're going to multiply 5 times 2 fourths plus 5 times 3. So 5 times 2 fourths plus 5 times 3. Okay, so what is 5 times 2 4? Well, it's 10 fourths. 10 fourths plus 15. So far, the answer is 15 and 10 fourths. Okay, but again, this numerator is bigger than this denominator. So that means that this part here is bigger than 1. So we can add those ones to here, to this number here. So let's figure out what 10 fourths actually is. So I know that every 4 out of 4 equals 1 whole. So how many of those 4 out of 4s can I get out of here? Well, I know that I can get 8 fourths, and we know that's not equal to 2 because 8 divided by 4 is 2. So that's 2 wholes. So 8 fourths. How many additional 4s do I need to get to 10? Well, that's 2 more. So that means that 15 and 10 fourths is equal to 2 wholes. 15 plus 2 wholes plus 2 fourths. So that means this is 17 and 2 fourths, which is the same as 17 and a half. So all of these answers are going to be valid, right? 17 and 2 fourths, 17 and a half, and also 15 and 10 fourths are all equivalent answers. Okay, now to solve this one. 12 fifths times 6. Okay, so let's use a different color for this one. So we're going to multiply this whole number by this numerator, and we're going to keep our denominator. Okay, so this is going to give us 72 fifths. Okay, so an easy way to convert this improper fraction into a mixed number, because again, we definitely have more than 1 whole here, because every 5 fifths is a whole. So remember that fractions are division. So 72 fifths, that means 72 over 5. That means 72 divided by 5. So we can go ahead and do that division. Okay, so let's go ahead and do that division. So we're going to take 72 and we're going to divide it by 5. Okay, so what is, how many times can 5 go into 7? So let's use the standard algorithm for this. So it can only go one time. So I know that 5 times 1 is 5. I'm going to have to erase this. I'm sorry. I need some space. Okay. All right. So we're going to do a subtraction here. 7 minus 5 is 2. And this 2, we're going to bring it down. We're going to bring it down. So now I have 22 here. So how many times can 5 go into 22? Well, that is 4 times. Because 5 times 4 is 20. So how many do we have left? We got 2 left. So that means that 72 divided by 5 is 14 wholes, right? So it's 14 wholes, but we have a remainder of 2. So this remainder is 2 to what? 2 fifths. Okay, so this is our answer. 14 and 2 fifths, which is the same as 72 fifths. We just converted this improper fraction into a mixed number. Okay, let's try the next one. Here we have 13 fourths times 5. So we're just going to multiply this whole number by this numerator, and we're going to keep our denominator. So 13 times 5 is going to be 65 fourths. And again, we're going to use the same method. Is that 65 fourths just means 65 divided by 4. And we're going to go ahead and do this division. So 65 divided by 4. Okay, so let's use a standard algorithm here. So let's go one digit by 1. So 4 goes into 6 how many times? So 4 times what can get me as close to 6 as possible? Well, 4 times 1. That's 6, because the next one is 8. And that'll be over. So 4 times 1 gives me 4. So I'll subtract it. 6 minus 4 is 2. So I have 25 left. I'm going to bring down this 5. But this is an arrow here. Okay, so 4 times what can get me as close to 25 as possible? Well, I know that 4 times 5 is 20. So 4 times 6 is 24. So it has to be 6. So I can get to 24 here minus 24. Okay, so I have 1 remaining. Remainder 1. Okay, so my answer is going to be 16 wholes. 16 wholes, remainder 1. 1 what? 1/4. So 16 and 1/4. So 65 fourths or 16 and 1/4. All right, thank you very much, class. I hope that you were able to understand, use this video to your advantage.